In this video, we're going to start looking at a series of 5 important lemmas. By the end of these 5 important lemmas, we will be able to show that the textbook's definition of group and the definition of group that I have introduced and am using are actually logically equivalent to each other. So our first lemma is going to look kind of strange. So this is what the statement of lemma 1 says. Let's let G triangle be a group. And we're going to let A be an element in G. And the lemma says that if A triangled with A is equal to A, then it turns out that A is actually the right identity for the group. In other words, it's equal to ER, where ER is the right identity from axiom 3 of the group axioms. Well, how are we going to prove this particular thing? Well, let's look at this. We know that since A belongs to G, there exists somebody that I will call a hat in G that is a right inverse for A. In other words, I already know that by axiom 4, there is an A hat such that A triangled with A hat is equal to ER. That is axiom 4. And now I'm going to consider the main hypothesis. Our main hypothesis in this particular lemma is this statement here. We are assuming that A triangled A is equal to A. In other words, we are going to assume that A triangled with A is equal to A. Then we get the following set of implications. I can post-multiply this equation by A hat. In other words, I can say that A triangled with A equals A implies A triangled with A triangled with A hat is going to have to be A triangled with A hat. Now, if we look at it, I know that this side's going to be E, but before I use that, I'm going to reassociate. I'm going to put the parentheses in a different place over here. The second group axiom allows me to rewrite the left-hand side of this as A triangled with A triangle with A hat. And of course, that is A triangle with A hat. This is by axiom 2, by associativity. Now what I want to do is I want to realize that axiom 4 kicks in. The choice of how we defined A hat says that this expression here is equal to E, and this expression is equal to E. So I want to say that that equation that we're currently looking at says that we have A triangled with ER is equal to ER, and I know that I can go from this step to this step by axiom 4. A hat is the right inverse of A by axiom 4. But of course now axiom 3 kicks in. A triangled with ER is just another name for A, and there's nothing to do on that side. So we get this particular statement, and this is by axiom 3. The fact that ER is a right identity element. And that completes our proof. In other words, we have now proved that if A triangled A is equal to A in a group, then A is equal to ER.